All right, good morning. Now we're going to go ahead and solve your part C, which is solving for specific heat capacity. So a thermal dynamic question, solving for heat capacity, specific heat capacity. So I'll just go ahead and write them all down here. 6 kilograms, 82 degrees Celsius. It's placed into 2 liters or 2 kilograms of water, and that water is at 54 degrees Celsius. The final temperature is, final temperature of 54 degrees Celsius, and this temperature is negative 31 degrees Celsius. It's a big ooh. Determine the specific heat capacity, that's my unknown, of the unknown substance, and the specific heat capacity of water is right here. So what are my known values? Well, there's my CP of water. Here's my mass of the unknown. Here is my temperature initial of the unknown. Here is my mass of the water. And here's my temperature initial of the water. And finally, here's my temperature final. So I could write all those down, but I'm going to go ahead and skip past this and say I need to know the specific heat capacity of the unknown value. The equations will be Q equals mCp delta T, and the Q, the energy transferred of the unknown, will be equal to the energy transferred for the water. So going ahead and plugging those two in, I'm going to say it's the mass of the unknown times the specific heat capacity of the unknown times the change in temperature of the unknown equals the mass of the water times the specific heat capacity of the water times the change in temperature of the water. Plugging in, I don't know the mass of the unknown, so that stays. Sorry, I do know the mass of the unknown. Whoops. 6 kilograms. I don't know its specific heat capacity. I do know its change in temperature. It went from 82 to 54. So that's dropping 28 degrees Celsius. And the mass of the water is 2 kilograms. Specific heat is 4184 joules per kilogram degrees Celsius. And the change in temperature of the water, it went from negative 31 to 54. So what is that difference? Well, it's 54 minus a negative 31, which we all remember from math class becomes plus a positive, or 85 degrees Celsius. All right. Now we'll go ahead and do the math, which calls for us to multiply first. So 6, I can't do times the specific heat, but I can do times 28, and that gives me 168. So specific heat capacity of the unknown sticks, and I'm going to have 168 kilograms times degrees Celsius equals 2 times 4184 times 85, 711280. The kilograms canceled, the degrees Celsius canceled, so that's just straight up joules. And now I've got to divide by 168 kilogram degrees Celsius. The kilograms and degrees Celsius and 168 cancels over here, which leaves just the specific heat capacity of the unknown that we wanted to solve for. And if I divide that by 168, I get my answer, which is 4,233. And I think I said 3 decimal places, which it becomes 8095. So 3 decimal places means that would be 810, and that is joules per kilogram degrees Celsius. Thank you for watching. As always, smash that like button, ring that bell, and holler at your boys in the comment holler at your boy in the comment below. Thank you.